Good evening, everyone. This is the last part. I think I'm the person between you, all the awards and dessert, so that's a dangerous place to be, I understand that. So I'll try and be quick and try and be entertaining about the whole thing. I'll just take you on a brief adventure. You could go over to the next set of slides.
Well, I will assist you in
Okay,
that.
I'm sorry. Okay, first thing is take your checklist, grab the equipment you need before you go.
Yeah.
Thank you.
Okay.
It's always good to have a second to keep you out of trouble, too. The adventure, it talks about learning, about making, about computing, the adventures of NASA in history through these different parts there, and one aspiring astronaut who was following them along through all these different pieces. Making in NASA starts with about the Apollo program. Back in the 1960s, of course, we put a big commercial plug in. 50 years ago this coming weekend, we put the first people on the moon, and it took a lot of innovation. As President Kennedy said, we had to go invent things that had not been invented yet. We were going to get there. And we learned things we had never seen before. Technology still had a ways to go. This is the computers we use on the lunar module landing down there. Look at those green lights there. That was the entire, those were the LEDs. You talk about dots per inch. These were not dots. Those were the pixels themselves. And there's what got us from the lunar surface, from the lunar surface module to the surface of the moon and back up off the lunar surface again. And two crazy astronauts bet on this thing working. Making was also part of keeping us alive. On the Apollo 13 mission, we had to use the lunar module as a lifeboat. It turns out that the lunar service module and the lunar module were made by two different contractors on two different coasts of the country. One of them had square filters to scrub the carbon dioxide out of the air. The other one had round filters. And so when the lunar module became our lifeboat, and it was only designed to hold two people for about a day and a half, became a lifeboat for 3 astronauts for about a week. We had to figure out how to make those square filters in the service module fit in those round holes in the lunar module in a matter of hours. When you hear that phrase about failure was not an option, this is what they were referring to. Otherwise, the astronauts are going to die of carbon dioxide poisoning within hours of this emergency happening. And they came together with things like cardboard tubing that was on there. They used rolled up checklists. They used socks to create something that kept those guys alive long enough for them to get back to the ground. So it was making under duress, but it worked. About that time, I was in first grade, and I watched the Apollo 7 launch. And about the time I already decided I was going to be a pilot, and the principal comes into the office, into our classroom, and I'm in the middle of arithmetic, and I'll confess I did not enjoy arithmetic. If I have 5 apples and I give 3 to Jenny, how many do I have? First off, what if I don't like Jenny that much? What if I want those apples? I was having a hard time with this whole concept of why I wanted to know about how many apples I would have left. Or what I was going to do with this whole handing out of apples to people I didn't care for. And she interrupts the class. The life was already looking up. She brings out the TV set, the old black and white ones with the rabbit ears. And life was getting better. We're going to watch TV instead of doing arithmetic. And we see this steaming rocket sitting on the pad, and they're counting backwards from 10. And when they hit 0, this thing goes straight up into the sky and disappears. Wow, what in the world was that? And she explains to us, I wanted you to see this, know where you were when this point in history happened. This is the beginning of our journey to the moon. Now, I was 5 and a half, and I knew a thing or two. And I knew that was just crazy. The moon was all the way up in the sky, and you couldn't possibly get there. She assured me that we had a plan, and we were going to get there and keep your eyes on these folks. So I watched them closely, and about next July, 50 years ago, they were walking around the moon. And I was thinking, man, how do I get to do that? How much do I have to pay? What kind of job do I need to have to go do that? And my dad explains to me, well, if you're an astronaut, they pay you. They pay me to go walk on the moon? He says, yeah, this job is called an astronaut. You got to, well, sign me up for that job. And he told me about, well, you got to get good grades. You got to stay out of trouble. You can't talk back to your parents. I said, well, how about 2 out of 3? But then I knew I wanted to know math. I didn't care for math very much at that point. I would learn years later that there are all the cool things you could do with math, and it wasn't just math for math's sake. You could save people's lives. You could put ships on the moon. You could do all the kinds of fine things with it that got me inspired about it. But that was where it got started, was under the Apollo program. By the late 70s, we had Skylab. Skylab computer technology had progressed a little bit more. On the right side, I'm sorry, your right side, you're looking at that giant bank of switches thing. That was the computer, and it had the complex job of pointing a telescope. You see the early precursors of a mouse. You see a couple of 2D things. You can move things around up there in a cathode ray tube scope. They didn't have any words. It just tells you what died on that particular piece out there. We had come a long way since the Apollo program. On the right side, you see is when we launched this thing, it was damaged. And so one of the solar rays didn't come up, and this thing couldn't cool itself. It was 130 degrees out there when the first set of astronauts showed up. And the only way we were going to have to cool this thing down was to put a blanket over to protect it from the sun. And so we made one. What you see there are women at sewing machines there, I think at Goddard Space Flight Center, putting together the protective blanket that they would go out on a spacewalk and string across. A pretty low-tech solution to a very high-tech problem. But it worked, and we got 3 consecutive successful missions out of Skylab because of that. I was in high school at this time watching all this adventure unfold. And when I got to high school, there was this old broom closet, for lack of a better term, where there was this weird-looking typewriter. It had a roll of yellow paper in it. It was called a terminal, a teletype machine. There was no explanation. There were no instructions. Just a bunch of us curious students in there going in there after school looking for trouble. We found out quickly that it was connected to a mainframe computer somewhere in the bowels of D.C., and that we were able to hack our way onto it. We also found out there were these things called tapes, yellow tape with holes punched in them, and each of them had things called programs. One of which we found was a lunar lander program where you put in the amount of fuel you wanted to burn, and you either crash and burn on the lunar surface or you would land successfully and you could do a victory dance. This wasn't on any kind of screen. It wasn't a video game. It was just literally you're just typing things out on a yellow sheet of paper that was putting out reams. For some reason, we never got busted by the faculty. We never got run out of there. They put up with us, and we thought we were having a final time because we'd hacked our way into this system long before that word hacking ever entered the human language. Finally, we got as far as we could go with this whole thing. We realized that we needed to do things like be able to write program code if we were going to make our own different games and go have fun with it. So we finally fessed up to our teachers, like, look, we've been in here playing with this computer, and we want to do some more with it. Well, you have to learn things like machine language and Boolean algebra and basic programming code. And the teacher's reaction wasn't one of giving us detention. They said, you come in on lunch hour, and we will teach you these things. Now, the teacher had never taught Boolean algebra, didn't even know what it was. The teacher taught himself Boolean algebra and came back and taught us. Taught himself basic programming and came back and shared that with us during our lunch hour. Of the 3 of us who managed to talk the teacher into doing this, one became an astronaut. One is now a professor of economics at the Chicago School of Economics. The other one is a Microsoft certified engineer who makes some of the software you use on your computer today. So 1 out of 3 ain't bad. By the time I was in college, it was a shuttle program, and the shuttle program had its own technologies out there. We did have cathode ray tubes, again, one of the first space flying vehicles that had that with text, and that's how we interfaced with this thing. When you were moving the stick on the shuttle, there was no wires, there were no bell cranks, there was nothing connecting you to the flight control surface. You were telling the computer that you wanted to turn right, and the computer wanted to listen to you, it would turn right. What you see on the left is making there too. We were doing satellite servicing, and this particular satellite was bucking and turning and having all kinds of issues keeping itself under control. And the first astronaut to go out there and try and ride that bull got thrown. And so they had to figure out how to get the flight control system to kick on. There was a switch, and we also had to get 3 astronauts out there and try and wrestle this beast back down. They made a fly swatter, they called it. It was a big tube with a big piece of paper and something they could reach out there and touch the switch and put it in the proper position so it would stabilize itself, and we could bring it aboard and repair the satellite. Again, making by necessity. During this time, I was at the Air Force Academy. I had been through torturing my physics teachers all through high school. I'd gotten through advanced placement physics and had a year of college where I'd gone through some of the killer courses in physics at the University of Delaware, and I had about enough physics. So when I was going through basic training at the Air Force Academy, and they were talking about this curriculum of core physics courses, I was a little bit just brazen enough to go, hey, look, why don't you give me your final exams and all your core physics courses? And if I pass them, whatever grade I pass it with, you give me that grade. And if I fail, I'll take the course. He looked at me like, what? But they gave me the test. And about a week later, I was summoned to see the Dean of Physics at the Air Force Academy. Now, I've been there all of 7 weeks. My hair hasn't even grown back from basic training. And I'd never seen a colonel in the Air Force. And here he was with his flank with his entire physics faculty and staff standing around him. And I walk in there going, this is where they're going to accuse me of cheating or something. I don't know what I did wrong. And he goes, son, we've never had anybody in the history of the Air Force Academy test out of our entire core physics curriculum. And I was like, I was about to make my excuses, like, hey, look, I've been through all this before. This isn't anything new. And before I could get a sentence out of him, he says, have you ever thought about being a physics major? I said, I just tried to get out of physics courses. You want me to sign for it? And his deputy just piped right in. He goes, you ever thought about being an astronaut? I said, yeah, once or twice. He says, well, you come out of the academy with a good technical degree with a decent GPA, and then you go to pilot training, and if you're a halfway decent pilot, you can become a test pilot. He says, and who knows, every single one of our Air Force astronauts was a test pilot. He had laid down a flagstone path to the stars for me, and I was just young and gullible enough to believe him. I signed up on the spot for physics. I also signed up for astronautical engineering and worked my tail off at the Air Force Academy and came out of there. 16 years later, after going through all that, after going to pilot training and getting those technical degrees and becoming a test pilot, like every other test pilot and engineer out there, like in that ad I was talking about, I signed up. I put in, and for some reason they hired me. And I got to go fly. And then it was my turn. I was on one of the local public radio broadcast shows in Washington, D.C., and they're asking about how I got started with this. And I told the story about my principal coming in and getting me all excited about going into space. And I called her out by name because I was sure at that point she was dead. She was not. What's more, one of my tattletale classmates thought it'd be a good idea to take an MP3 podcast of this particular interview and let this principal know that not only had one of the people she inspired gone on to become an astronaut, but was publicly calling her out for it. This was a nun. Have you guys ever seen the Blues Brothers? I was summoned to the convent in New Jersey by my principal for what I'd said about her. It turned out we had a good dinner and we had a good catching up with each other along with the other teachers out there. But it gave me the idea that for my next launch, why not invite all my teachers down to watch that launch? They were just as much responsible for this as my parents, as my neighbors, and all the people out there doing hard work to bring me out to that particular launch. And they came down. They were wilder than I remember them being when I was in school. Computing on the space station is a 21st century thing. After a lot of sturm and drang and fighting, we convinced the designers that we should have a local area network. And it's the busiest thing up there. We've got like 3 or 4 now. One for controlling controlling the space station, one for communications, one for just land stuff, email, VoIP. One of our favorite tricks is calling up Domino's and seeing if they'll honor their 30-minute guarantee to the space station. Listening to satellite radio while you're flying around the Earth on a satellite. Making has become less of a contingency thing and something with a little bit more of a pre-planned thing now. You see Made in Space, which is our first 3D printer that works up in 0G. It's making little plastic things, but it's just verifying that we can actually overcome the challenges of being in microgravity and still print things. The next evolution of that is going up in October. The Russians are doing a tissue printer in 3D, cartilage, bone, things like that. So first off, if you have an injury in space, we can actually do things that are reconstructive for you. Another part is there are things out there that are probably too delicate to be manufactured in one gravity. You can make it in space and it sets, and you can bring it back down. So you can do things like that. And more on that in the next slide in a little bit. So where's next? Mars, Moon, and beyond. When I left the astronaut corps, one of the first things I got to work on was this mission to go out, a crew module going out to Mars. And we got to do cool things like thinking about How do you solve the problems of being out there in these long ways? How do you communicate with Earth when you're 20 light minutes away? And you send a text message, hi, and 40 minutes later, somebody calls, hi yourself. How do you do things like surf the internet when you are 20 light minutes away from Earth? You talk about some bandwidth problems there. So I got to do things like call up Google and go, how do I fix this problem? And they show up in numbers and want to work on this with you. That's pretty cool. And making, well, one of the things we generate lots and lots of trash. And it'd be nice, a lot of it's mylar, a lot of it's plastic. Can you take that stuff and recycle it? We're already recycling a lot of our human waste and pulling the impurities out. But this time, I'm not just taking the impurities out, but actually taking the plastic itself, turning it back into feedstock for our machines, and making things that we need while we're on our way. Ultimately, we're leading to a thing called in situ reutilization, where we make things like fuel and other supplies that we need on the very planets we are, so we don't have to take tons and tons of supplies out to these planets to go do that. The technologies are going to be way beyond what we have right now. Just as Kennedy said about Apollo, we're going to need to invent things that don't exist right now. And this is where you come in. This is my co-conspirators. We're going to need not just computers, we're going to need things like artificial intelligence, things that know when something's broken on your spacecraft, how much of a threat it is. Do you need to replan your schedule? Is there a new trajectory you have to go on? That whole Apollo 13 thing doesn't work when everybody's 20 light minutes away. You need to put all of Houston in a box or set of boxes. Things like computer screens and keyboards have to go away. The interface almost has to be virtual. Everything you're touching is connected to a computer, that Internet of Things, except it's not internet, is your spacecraft now. Making. We just talked about the fact that we have to go and reutilize the waste products we use, but we're going to have to make the places that we live where we go. Because right now, just to get things to orbit costs about $10,000 a pound. Why take all that stuff to Mars or take it to the moon when all of it's sitting right there? But I don't have factories to go put there. Can I do those things now? So those things I need to go figure out. And then how do we get there? How do we keep people safe? And how do we bring them back? How do we develop the propulsion technologies? It's you are the folks who are going to inspire the folks who do those things, who invent those things that don't exist yet, who do show up at some point and go to Mars and come back and then blame it on you. So I invite you to inspire with me and think about how we're going to get there in the coming years to take us further out into the solar system. Thank you.